In this lesson, we're going to continue talking about operations with radical expressions, but this time we're going to be talking about the operation of division. And we've already reviewed those 3 bullet points where a radical expression is considered simplified when. We've already talked about number 1 in the last section, and that was when the radicand had no perfect square factors other than 1. Today we're going to be focusing on bullet point 2 and 3. Number 2 is that the radicand contains no fractions. So if you have a fraction, I'm going to show you how to eliminate that. And then the third one, no radicals appear in the denominator. So if you ever have a radical in the denominator, I'm going to show you how to eliminate that as well. And for a radical expression to be simplified, all 3 of these must be satisfied. So we already learned about how to do number 1. So let's go ahead and learn how to do number 2 and 3. It says here, divide the following radical expressions. And you can see that the radicand is a fraction. Do you see that? So it doesn't obey the second bullet point here. So to eliminate the fraction radicand, I'm going to do something that looks like this. And it's pretty easy. I'm just going to kind of break it into 2 separate pieces. Because now, by doing this, I have satisfied that second rule. I don't have a fraction as a radicand anymore. So that's good to go. But do you see what it caused? It caused us to kind of move into the realm of number 3, where it says no radicals appear in the denominator. Well, by breaking that into 2 pieces, it caused me to have that radical in the denominator. So here's how you eliminate it. It's called rationalizing the denominator. And to rationalize it, what I'm going to do is I'm going to multiply the top and the bottom by that denominator radical. See that? That's called rationalizing the denominator. Now, watch what that simplifies to. If I look here, I can see that my denominators are root 5 times root 5. And root 5 times root 5 is actually equal to 5. Well, how did I know that? Well, think about it. 5 times 5 is 25, right? And the square root of 25 is 5. So that's one thing you could do. Now, once you're done with that piece, you have to do the top. So the square root of 12 times the square root of 5 is the square root of 60. Now, I know I'm kind of smushing this in here, but I wanted to show you. Now, I have the square root of 60 over 5. But do you see how now not only number 2 is satisfied, now number 3 is satisfied, but now I'm back to number 1. The radicand has no perfect squared factors other than 1. Look at the numerator. Do you see how the numerator is the square root of 60? Can I break that down a little bit more? I think I can. So I'm going to pull him over here to the side, and I'm going to use my simplifying skills to break this number down. I can use my Desmos calculator to help me find those 2 factors. But it looks like my factors are going to be 4 and 15. So I'm just going to do a little bit of simplifying off here to the side. And I'm going to simplify that down to 2 times root 15. You see that? So really, this just simplifies down to 2 root 15. Now, I'm not done. I'm actually going to take that, and I'm going to replace it with the square root of 60. So I'm going to say 2 root 15 divided by 5. And at this point, I am fully simplified. I'm not always going to be fully simplified. I might have to do a little bit more simplifying here. But for now, we are completely done. And this is your answer. All 3 of those statements above have been satisfied. All right, let's try another one. 2 root 5 divided by 3 root 8. Obviously, there's a lot of stuff going on here. Looks like all 3 of those rules are not being met right now, so we need to simplify. I'm going to start this one by trying to get rid of that radical in the denominator. I think that's a good place to start. To do that, I'm going to rationalize the denominator. So I'm going to multiply the top and the bottom by that root. Don't include the 3 there because the 3 is not a square root. It's just a 3. So this is kind of the tricky part. You really got to pay close attention here. Looking at my denominator, I know I have the square root of 8 times the square root of 8, which is 8, right? That's going to create an 8. But I also have this 3 that I need to multiply it by. So it's going to be 8 times 3. So my denominator is going to be 24. Did you catch that? And the numerator, it looks like I'm going to have 5 times 8, which is 40. So 2 times the square root of 40. Now, I eliminated that radical in the denominator, but look, the top is not simplified. So I need to go ahead and take that numerator, and I just need to kind of pull him off to the side, and I need to simplify him. So that's why simplifying is so important in this unit. So I can think about what my factors are here, and I want the factors of 40. So I got to kind of think about that for a second. It looks like it might be 10 and 4, right? So 2 times 4 times 10. And I can simplify that down to 2 times 10, which of course simplifies 4 root 10. So I'm going to take that piece and I'm going to bring it up and I'm going to replace it. So that's going to leave me with 4 root 10 divided by 24. Now, when I get to that point, this is where I'm done, but in this problem, I'm actually not done, because do you see how this can actually be simplified? 4 and 24 are just numbers, right? They're not radicals. So I can actually simplify 4 over 24, right? That's going to give me 1/6. So really my answer can simplify down to root 10 over 6. Of course, with that invisible 1 out in front of the square root of 10. And there you have it. You are fully simplified. All right, I have 2 more examples for you, and I know they look really complicated, but I just added a couple of variables in there, and we're going to use the exact same process, but we're just going to use our skills on simplifying variables now. So let's go ahead and look at the first one here. Hopefully your eye is kind of tuned into the denominator and that radical. Let's go ahead and just eliminate that radical right off of the bat. I'm going to rationalize the denominator by multiplying the top and bottom by the square root of 3m squared. So go ahead and take a moment and do that. All right, and it looks like the bottom, watch what that's going to give me. Remember, 3m squared times 3m squared is just going to give me 3m squared, right? So really this is saying 4 times 3m squared. So the bottom here is going to be 12m squared. The top looks like I really can't simplify anything. I'm just going to multiply them together. So 5 root 3m squared. So it got rid of the denominator radical, but now let's take the numerator. Let's take them off to the side, and let's go ahead and simplify because we have to do that. All right, so remember this breaks into 5 times the square root of 3 times the square root of m squared. So if I simplify that all down, it looks like it's just going to simplify down to m. So I have 5m root 3. I'm going to take that piece and I'm going to replace it, right? Replace it in there. So 5m root 3 divided by 12m squared. Now, this is the point where most likely you're going to be simplified, but in our case, we're actually not. We have to simplify a little bit further. So 5 divided by 12, well, that doesn't simplify, so I'm just leaving it as 5 over 12. But look at the m's. Now I have to use my laws of exponents. Remember those? Laws of exponents? I have m and I have m squared. So think about it. I've got 1 in the top and I've got 2 in the bottom. That's going to leave me with 1 in the bottom whenever I simplify it using the quotient rule. If you need a refresher on that, go ahead and check out the laws of exponent video. And then I'm going to be left with the square root of 3 up top. And there you have it. You are fully simplified. And the last one here, let's go ahead and do this. Let's go ahead and begin the problem by rationalizing the denominator. So there we go, square root of 8, square root of 8n. All right, now let's go ahead and do my denominators here. 8n and 8n, they create 8n, right? So it's really 7 times 8n, right? So that's going to be 56n. And my numerator, it looks like, let's piece it all together here. 2 times the square root of 24. I'm going to use my exponent rules again. N cubed times n is going to leave me with n to the 4th because I'm going to add those exponents. I'm going to do that same process. I'm going to take the numerator. I'm going to drop it down here. And I'm going to go ahead and simplify it. 2 times 24 times n to the 4th. 24 can break down into 4 and 6. And n to the 4th breaks into n squared. Keep simplifying things down. And now we have 4n squared root 6. That's just the top. Remember, that's not the final answer. That's the top. So here we go. 4n squared root 6 divided by 56n. You see that? All right. You're probably noticing it is not simplified, right? So let's go ahead and simplify it. Let's do the coefficients first. 4 over 56 gives us 1/14. So I'm just going to do a 1 over 14. I have n squared over n leaves me with an n up top and then root 6 in the numerator. So instead of writing that 1 there, I'm just going to go ahead and rewrite it. N root 6 over 14, and you are finished. So you can see that's a huge process. There's a big procedure here to really practice. But with a little bit of practice, practice makes perfect.